बाबर सर स्टार्ट करूया. नवले सर आहेत का तुम्ही?
हो आहे. चालू करा.
ओके. सांगोला तालुका शेतकरी शिक्षण प्रसार सांगोला विज्ञान महाविद्यालय सांगोला, Department of Physics in collaboration with Internal Quality Assurance Cell, organizes an international e-conference on recent trends in nano-materials and its application 2022. Here it is second day of the conference. As a convener of the conference and on behalf of my college, I welcome Dr. Babar, Mohandas, all resource person, delegates, foreign invitees, research student and scholars on this digital platform. Yesterday, we have completed the conference in 3 different sessions. And today, we have 4 different sessions including valedictory function. Once again, I welcome you all and I would like to hand over this session to Dr. Babar by his introduction. Now it is my great pleasure to introduce Dr. Appasaheb Babar. Dr. Appasaheb Babar is ex-student of Department of Physics, Vigyan Mahavidyalaya, Sangola. He did his MSc and PhD Shivaji University. He is now assistant professor in Department of Physics, Shankarao Mohite Mahavidyalaya, Akluz since 2013. He did research on transparent conducting oxides, gas sensor supercapacitors. Dr. Appasaheb Babar is honored by late Dr. B.S. Patil Memorial Prize by Shivaji University, Kolhapur for having stood first in the subject of physics at BSc held in April 2006. He got a open merit scholarship at MSc degree during 2006 to 8. He received UGC Merit Years Junior Research Fellowship in year 2009 to 11. Dr. Appasaheb Babar has published 32 research articles in well-reputed journals. He has published 4 research articles in national journals and 9 research articles in proceedings. Dr. Babar has written and published 1 book. He has presented 42 research papers in national and international conferences. He is associate editor and referee of 2 different international journals. Dr. Babar, he is having, or his research article got cited by 949 times. His H index is 30 and ITN index is 14. With this, I invite Dr. Babar to chair the session of international conference. Thank you. Thank you so much. Over to Dr. Appasaheb Babar.
Thank you, sir. Thank you, Dr. Dasade, sir, for nice introduction and giving me opportunity as a chairperson for this today's session. Today is the second of this international e-conference on nanomaterials and its applications 22 RTNA 2022, organized by the Department of Physics, Vigyan Mahavidyalaya, Sangola, and the person for this today's session is the Dr. Sonai Muthu Mohandas in University, South Korea. It's my great pleasure to introduce today's speaker, Dr. Sonai Muthu Mohandas. Is there any problem, sir? Compressor, is there any problem?
Ask audience to mute their.
Okay, you start again.
Dr. Sonai Muthu Mohandas, currently he is working as a research professor in School of Chemical Engineering, University, South Korea. Now his interest includes synthesis of 2 additional materials with a biomolecule detection, synthesis of cyclohexane and its derivative using inclusion correctors, chemosense applications, computational applications. This is the research interest of Dr. Mohandas. Now, academic qualification of Dr. Mohandas includes he completed Bachelor of Science in Chemistry in 2005 from Rajya College, Rajya Durya Singham Government Art College, Siv Gangai, from Madurai Kamaraj University, Madurai. He has completed MSc in Industrial Chemistry in 2008 from Tamil Nadu. He has completed his PhD in Chemistry in 2016 from Algappa University, Tamil Nadu. Also, he has postdoctoral, he became a postdoctoral fellow from 2017 to 2020 from Taiwan as well as from South Korea. Now he is principal investigator of one of the major project in the School of Chemical Engineering, A&M University, South Korea. And now currently he is working as a international research professor, that is assistant professor in A&M University, South Korea. Now, he has published 42 research papers in various reputed national and international journals, which is having very good impact factor. Along with this, he has completed 16 research papers and books in conference proceedings, in national and international conference proceedings. He has also participated in 4 national and international conferences, 1 symposium, and 11 workshops. Now he has handled various instruments, various reputed instruments in his lab. That means X-ray diffractometer, XRD, FESEM, thermogravimetric analysis, FIR, AAS, UV visible spectrophotometer, electrochemical workstation. Also, he has handled several softwares in his lab. Now, we have such a great person along with us. I request to Dr. Sonai Muthu Mohandas to deliver his talk. Now, Sonai Muthu, sir, please, sir.
Dr. Mohandas, sir. Yourself. You are visible, but you are not audible. Unmute yourself. Your audio is on.
Now is audible?
Yes,
Yes.
Yeah, okay.
Yes.
So finally, I also thank to all the faculty members, staff members of Department of Physics and STS for giving me a wonderful opportunity to present my work on international and e-conference, recent trend in nanomaterials. Okay, now let's start the presentation. Today I am going to discuss some results from my lab on small molecule derived in photoluminescence carbon dot in synthesis and application in sensing and bioimaging materials. Okay, this is me and my professor. Just a minute. Now it's okay, right? Yeah. This outline my presentation. The following sections are included. The first one is in introduction section. The second one is in background and scope. The third one is in instrumental methods, and fourth one is in synthesis, characterization, and application. Finally, I'm going to present the summary and conclusion of these presentations. Okay, next, introduction section, carbon dots. So now I'm going to present about the carbon dots. First of all, what are the carbon dots we should know, and also we have to go the further application studies. And then the synthesis methods of in carbon dots and properties of carbon dots, and also in applications of carbon dots. So what are the carbon dots? Carbon dots are small carbon nano particles less than 10 nanometer size with the same form of surface association. Okay. The carbon dots were first discovered by Zhu et al. In 2004, accidentally during the purification of single-walled carbon nanotube. So carbon dots also have unique characteristics such as have a small size with relative large surface area, inexpensive methods, and easy surface modifications. Due to the unique properties, carbon dots have been extensively applied in different kind of scientific disciplines. For example, photocatalytic reaction, drug gene delivery system, in vitro and bioimaging applications, chemical and biological sensing, as well as the photothermal therapies. Next, the carbon dots. The carbon dots are classified into 3 categories. The first one is in graphene quantum dots, and the second one is in carbon nanodots, and third one is in polymer dots. The carbon quantum dots contain 2 graphene layers, including chemical groups on the edges, which is derived from the reactant originating and carbon source from the subsequent reaction. On the other hand, in carbon nanodots is spherical shape and give a crystalline graphic like lattice structure, and also in amorphous structure in carbon nanoparticles. Finally, the third one is in polymer dots, can be either in cross-linked aggregated linear polymers or polymer chain aggregated and around in spherical and carbon core. Okay. The next, synthesis methods of carbon dots. Carbon dots can be synthesized mainly in 2 different routes. The first one is in top-down approach, and the other one is in bottom-up approach. What is top-down approach? Yeah, top-down approach refers to the larger carbon structure via in chemical oxidation or discharge, arc discharge or electrochemical oxidation, and also the ultrasonation method. However, the drawbacks of this method in top-down method includes a requirement of very expensive materials, and also in very difficult reaction condition, and all. Moreover, it will take in long reaction time. The next one is in bottom-up approach, chemical method. Bottom-up approach is to the conversion of small carbon structure to the desired size of the carbon dots. Okay, so this bottom-up approach is consisting. We can use the hydrothermal method and ultrasonic treatment. Also, we can use this one, and also in thermal decomposition, carbonization, and microwave synthetic, and finally the solvothermal method also synthesis to carbon dots. So here I am going to discuss about the bottom-up approach for the synthesis of carbon dots obtained from the small organic molecules. You can see from this in several examples of carbon source and small organic molecules. Okay. The next one is properties and applications. Properties, it has carbon dot has been in excellent water solubility. Okay. The biocompatibility, and also it has in good conductivity material and photochemical stability, and moreover the low toxicity and environmental friendliness of this carbon dots. And another one important one is in application part. Application part is in sensing and catalysis and optoelectronics, bioimaging and energy storage and photoluminescent ink applications. So first application is chemical and biochemical sensing. Okay, it has been reported in several studies of carbon dots. It can be act as a efficient sensor for detecting various metal ions and biomolecules and macromolecules, etc. And also it for in very small concentration values also we can use this one from this carbon dot. Usually the sensing is done by observing the quenching or enhancement. Most of the carbon dots detect with the metal ions is possible to quenching. Very few metal or few small molecules only getting the enhancement of the fluorescence carbon dots, because of the presence of the target species very important. Okay. So the different carbon dots have also helped in selective sensing, and where they can sense the target species in the presence of similar ions or molecules also. Particularly, carbon dots are widely used in the field of fluorescence analysis. You know very well about the fluorescence measurement because of the adjustable fluorescence or photoluminescence stability in these carbon dots. Okay, superior stability also it has, and also in good water solubility. This is also very important criteria. So the fluorescence carbon dots, it's closely related to the surrounding environment. Okay, in addition, the synthesis of carbon dots is relatively simple, very simple and easy to make this one. So the fluorescence sensing system can be roughly divided into 2 types of. We can do the analysis in different 2 types. The solution phase we can do the sensing, solid phase sensing also we can do. The solution phase sensing is by carbon dots can be well applied to the sensing various analytes such as cation and ions also. I am using cations and a small molecule also I am using from the solution phase method for sensing applications. Okay. The small molecules and macromolecules also we can use this one, and also in cell lines is very important application from this carbon dot studies. In comparison, solid phase sensing usually include in application, we can use the fingerprint applications. So you know very well about in anti-counterfeit fingerprint and security also. We can use, and moreover the test for our sensing material. So here I am using in solution method also in, I have applied this carbon dot, and also in solid phase also I have used it in this application. So another one application is bioimaging application. Okay, the most of carbon dot exhibit low concentrations. So we use increasing concentration potentially enhances the toxicity for the cell. Okay, some cases of carbon dioxide toxicity is increases significantly in presence of an external stimuli. External stimuli means we have to addition with any other catalyst or other things. So we no need to use it for a precursor and something. For example, carbon dioxide preparing through the hydrothermal bond of gravitic or non-toxic in absence of light. So no need to use any other external stimuli. So since cytotoxicity studies are extremely important for use of in material biomedical application, for the imaging or any other things, we have to study the first in cytotoxicity studies, and then we have to go further analysis of biomedical applications. Okay. The third one is in the photoluminescence single ink applications. So this one is in inexpensive fluorescence ink. We know very well about in anti-counterfeiting applications. Say for example, invisible security ink. We can use the banknote and other things in fingerprint have been developed using from this synthesized carbon dots. Okay. The next one is the background and scope of this method. The synthetic method for photoluminescence heteroatom doped in various precursors via one-step hydrothermal method. Okay. Another one is in the surface, we can for the surface analysis and morphological and elemental composition of the carbon dots are confirmed by different techniques, FTIR and BX, powder XRD and Raman, TEM, finally the XPS techniques also we can use. The prepared in the carbon dots area, small particle size in very good optical properties, and also it has been in excellent stability. This is also very important for in further biological and other applications. Moreover, this one is the excitation dependent photoluminescence properties. These are also useful in bioimaging application. We can get the different color imaging and a different sensing wavelength. This one. So the synthesized carbon dots can be employed for the detection of biomolecules or the metal ions in linear range. Concentration range from very wider, and then we can get the photoluminescence turn off or turn on. Previously, I said about in the photoluminescence intensities enhancement or quenching. The mechanism with we can get the very lowest limit of detection from this carbon dot with the sensing materials. In addition, the detection of biomolecules and metal ions, its happen is the quenching or enhancement also from this synthesis of carbon dots can be applied using the invisible security ink and the smartphone based color recognition application. Moreover, the carbon dots and its complex in aqueous solutions can be demonstrated for multicolor imaging. Multicolor imaging, previously I said something about in excitation. We have get the excitation dependent wavelength, means we can apply the multiple color imaging, bioimaging we can measure from this carbon dot with application. Finally, the proposed in carbon dot based sensing platform has promising future in specific or sensitive biomolecules or metal ions, whatever it is. The biological application and clinical application also we can use these studies. The next is the different characterization techniques for carbon dot synthesis application. The wide range of characterization techniques are employed to study the morphology, for example, the size and the shape of the structure, and also elemental composition from this XPS analysis and the crystallographic information from this powder XRD spectrum and the size distribution of various types of carbon dots from in hydrothermal method and other things. Okay. The next one is I am going to present the first topic is excitation dependent photoluminescence emission of nitrogen and sulfur co-doped in carbon dots for cysteine sensing and bioimaging and photoluminescence applications. Okay, this is schematic diagram shows the overview of my research work. The next one is schematic diagram of in cysteine detection. This is my synthesis schematic diagram. This is the procedure I use. This procedure. The preparation of the nitrogen and sulfur coated in carbon dots. Approximately, we have to take around 100 milligram of in this precursor material, 3 amino hydroxybenzene sulfonic acid. It is dissolved in from deionized water with 30 ml, and also the mixture was only heated for 10 minutes. We have to the thoroughly mixed solution was transferred into autoclave. Maximum quantity we can take in 50 ml because of in autoclave quantity is maximum with 80 ml. So and heated using the hydrogen method, we have to maintain temperature up to in 200 degrees Celsius maximum. We can use them 10 hours or 12 hours is enough for this hydrothermal method. So after the cooled the down to temperature, after the reaction was completed, okay, the yellow suspension we can get the used from this preparation carbon dots. It's getting in small sized high speed centrifuge. We have to precipitate the large particles, and then we can get the supernatant solution. Further, we have to go the dialysis. We have to use the dialysis membrane for dialysis with the deionized water. Maximum we can use the 24 hours or 48 hours. It depends on our the large particle, and remove the raw materials also. Finally, we can get the solid in carbon dot material were obtained in after vacuum for 48 hours. We can and then we have to further store this material for 4 degrees Celsius for further applications. The next one is in characterization method and the optical properties. First, we have to confirm the prepared in carbon dots by UV visible spectroscopy, and also further confirmation from this fluorescence spectroscopy. This figure A shows the typical absorption spectrum peak around the 219 nanometer is assigned to the pi to pi transition of in carbon double bond carbon, and solder peak appeared at around in 260 nanometer. This one is 260 nanometer. It's also in pi to pi transition. It also in coming in C double bond N bonds in the sp2 carbon of carbon dots. Moreover, the excitation band in 440 nanometer. This is the 440 nanometer. It's related to the N2 pi star transition of carbonyl bond. Effect on the very well about in surface of the nitrogen and sulfur in carbon dots. Okay. The carbon dot solution was basically in colorless in daylight, but after turning the UV light radiation, it's getting in green, bright green, and under 365 nanometer UV lamp. Okay. The next one is in photoluminescence spectroscopy. The getting from this in carbon dots in aqueous solution, and also confirmed by the UV spectroscopy, and then get the resulting the same solution. We have to optimize the carbon dots in exhibited in the excitation dependent behavior. Previously, I explained like this statement in the behavior. It's happened to maximum 300. You know very well about this 300 to 320 is the first one. Black line is 300 nanometer, and 320 is the blue line nanometer. It's only in decrease the photoluminescence intensities, and also the 330 to 350 is it will getting in more enhancement. And also in other hand, the carbon exhibited a strong and stable emission. It's getting in 513 nanometer. Here you can see this one. Excitation, maximum excitation and maximum emission is 531 nanometer. It's getting in high photo stability and with the photoluminescent independent behavior of excitation. Previously is a dependent behavior in getting, and maximum photoluminescence intensity we can get the independent behavior. Okay. The next one is in surface and morphological characterization. The surface and morphological confirmed from the FTIR and TEM analysis. The FTIR spectra revealed from the band around in 3000 in 3300 around 50 centimeter, and also 3200 and something it were assigned to the hydroxyl or a amine function is stretching vibration. And then major peaks appeared in 1400 and something around, just I explained around 1450 or 2300 and 300 something. And also in 1210, these peaks are which assigned to the stretching vibration. It is in assigned to CN stretching and SH and CS and C bonds indicating the presence of nitrogen and sulfur doped surface of carbon dots. And then confirmed from this in XRD confirmation, this carbon dot exhibit a broad BXRD 2 theta peak around the 25.5 degree, which is attributed to the 002 plane of gravitic carbon. Okay, and also we have to confirm the Raman analysis from the surface analysis. It is showing the two major peaks at in 1576 and 1361. Also, we can get the corresponding to the two different bands, the G band and D bands. It's we can call it the sp2 and the sp3 hybridization. The both bands were accompanied by the vibration of sp2 and sp3 carbon atoms in hexagonal and two-dimensional terminal phases. Also in it's happened to in graphitic disorder carbon dots. And the relative intensities of both D and G bands also we have to found to be the maximum average in the 0.94. It is also in well arrangement of gravitic carbon nature of these carbon dots. Okay. The next one is the morphological confirmation. We can see from this in TEM analysis, the lots of particles is obtained in the almost in 100 particles we have measured from this in diameter ranging from 3 to 7 nanometer, and also another one is figure E is also we can get in very large size of the particles. Maximum this is around range from 3 nanometer to 7 nanometer, and also we can get the average diameter is maximum 4 nanometer. And also it's in we can confirm from this latest print in 0.23 nanometer. It also in corresponding to the crystallographic phases for 100 arrangements. Okay, the next one is the XPS analysis, elemental composition. So this the survey spectrum. The first one is the survey spectrum of in carbon dots obtained 4 different peaks, the nitrogen and carbon and oxygen and the sulfur. Also, it is getting in elemental composition percentage. The highest percentage is the carbon is 61.69%, and also the nitrogen 10%. And that is getting in 6.6 and sulfur and oxygen also 20%. Okay, and then we have to fig pitting for in carbon and other sources. We can get the C double bond O and C single bond O and C single bond S. And also in carbonyl group also we can get, it is getting from the 280, 88 and 80, 85 and 84 also electron volt binding energy. Okay, the next one is the nitrogen. So the 3 different peaks in 401.8 in NH. This also we can confirm from this peak pitting analysis. And another one is in the sulfur peak. Sulfur peak also we can get the S double bond O and also 2 different sulfur formation of S2P in 1/2 and S2P in 3/2 elements. Okay, and finally the oxygen spectrum is we can get the around 530 to 532 electron volt. We are fitted to the corresponding maxima to previously we confirmed from this one the C double bond O, and here also we can confirm the C double bond O and single bond O, and also appeared in CFO double bond C with a single bond O. The XV survey spectrum, this one. The next one is in selectivity of in cysteine reduction. So effect of various biomolecules, we can use the maximum the 10 micromolar for the photoluminescence studies. Here I have tested the different nucleosides molecules, the adenosine, the cytosine, guanosine, and other molecules, and also in important the metal ions, cations. I have used this final concentration 10 micromolar. So, and then we can get the photoluminescence spectrum from this in the enhancement significantly by the cysteine over the biothiols. So we are used here these 3 different biothiols, 4 different biothiols functional group. One is in glutathione, another one is in cysteine, another one is diethyl, another one is in methionine. Among the dithiols materials, cysteine only the strong interaction between the carbon dots are because of significantly enhanced the photoluminescence from this in around in 180 to the maximum 380 and something. Okay, so and other materials showed the little or no change in any photoluminescence. So it is indicated that the carbon dots have highly selectivity towards other metal ions and also in other biomolecules. So the cysteine molecule enhances the photoluminescent intensities more than other biomolecules and metal ions. We can see from these figures in A and B. And also the increase in quantum yield from this, we can calculate from this quantum yield, the used as a quinone sulfate is a reference one. It will get in 22.5%, indicating that carbon dot with the cysteine is different from that of in original carbon dot. Carbon dot it's getting I think around in 11 or 12%, and also we can get the addition with the cysteine with the carbon dots. It is getting 22.5%. So quantum yield also fully enhanced. The next one is in the selectivity of the sensitivity of in cysteine detection. So the photoluminescence intensity is that 513 nanometers. So it gradually increased with the increase in cysteine concentration, 0 to 10 micromolar. It is getting such a thing that the carbon dot solution could be used as a photoluminescence probe. And also in figure A in the insert, the green emission will appear in strong yellowish green color upon the addition of cysteine at various concentrations. So we can see from this photograph in blue color emission to green color emissions it's coming. So furthermore, the plot of the photoluminescence intensity changes from this wavelength around in 513 nanometer. It's showing enhanced efficiency. So we can calculate from this in 1 by and photoluminescence intensities B0 also in absence and presence of photoluminescence intensities versus in 1 by in cysteine micromolar range. So we can get the linearity from this in R square value 0.9161. So we can confirm from this plot in this complexation. This complexation is carbon dot in cysteine molecules getting in 1:1 complex ratio. So furtherly, we have to calculate the photoluminescence intensities from this limit of detection. 0 to 10 micromolar, it's found to be, we can calculate from this method, found to be 23 nanomolar. So actually we have to take in wide relay range from 0 to 10 micromolar. We can get the calculation method, and the maximum limit of detection is 23 nanomolar. So the result confirmed from this in carbon dots with the cysteine with good sensitivity and also in good selectivity, we can get the low limit of detection in aqueous medium. The next one is in biological applications. The important from this carbon dot application imaging, how to take in and we have to take first in cytotoxicity using the MTTT assays. So determine the ability of the both solutions, the carbon dot and carbon dot with sensing solution. We can use the different concentration from the 5 to 25 micromolar were added to the HCT cells. This is human cervical cells, and also we have to calculate the stability measuring the particle densities values. And after in 12 hours and 24 hours and 48 hours also we can measure whatever it is. So and then we can get maximum is 90 to 99%. We can get the cell viability from studies. Okay, so we can in further in imaging studies for the HCT cells and maximum micromolar concentration 10 micromolar cysteine with the fluorescence of carbon dots with the cis molecules. So after 24-hour treatment, including phase contrast and fluorescence and overlay of images, we can see that clearly from here, the phase contrast transmission of cells, so clear image here. Okay, significant changes in greenish yellow in green emission of in carbon dot with the addition of cysteine molecules confirmed the high sensitivity of the sensor complexes. Okay. Compare from this one, the first one is in this carbon, the first three, and then another one is in carbon dot with the cysteine molecules. It will getting in the bright green fluorescence imaging. Okay, the next. And another one application is the photoluminescent application. Because of the excellent photoluminescent properties, we know about I explained in previously the highest stability. So we can use the photoluminescent application. So we can use from this one. And, we have to clean the aqueous solution to loaded the marker pen. The available markedly available marker pen without any chemical modification. We can use the both solution. We can use this one for photo stability. Two different carbon dot and also in complex material. This figure shows the OU and ORD in most abbreviation is the Yangnam University. The professor, my professor Yangrapli. So written words in filter paper under the 365 nanometer. We have to use an UV lamp for 365 nanometer range, and therefore the prepared in the both solutions have considerable potential application photoluminescent pen, or we can use the security ink in real applications. Okay. The conclusion of this research work, we have successfully synthesized in excitation dependent multiple emission and also in nitrogen and sulfur coated carbon dots. The synthesis materials were characterized in the chemical composition and the structural analysis in the presence of functional groups relevant to the sulfur, particularly in nitrogen also. So we can get nitrogen and sulfur carbon dot possesses a strong photoluminescence and excellent water stability. The green emitting the carbon dots are demonstrated the highly selective and sensitive for the cysteine detection in importantly in aqueous solution without any solvent addition. So moreover, the use of these carbon dots, carbon dot complexes, we can use the photoluminescence ink for the satisfactory results. Okay, this work also I have published in Microchemical Journal in 2021. The next chapter is I am going to present this one silver ions based on luminescent carbon nanodots for multicolor pattern smartphone sensor and also in bioimaging applications. Okay, this schematic diagram shows the overview of my research work. The next one is the schematic diagram of synthesis method. Previously, I explained the previous chapter also, so I just skip this, just and so on, skip the slide, and I hope to move in the next slide. So this material also here confirmed the RTNA properties. UV visible spectrum, the phase visible spectrum, the prepared in carbon dots in article properties used in fluorescence spectrometry also. The first one is in absorption spectra, shows the excitation and emission and excitation spectra also, absorption and excitation spectra also. The carbon dot nano dot solution. The UV visible spectrum is three different one. For the first one is 230, 220 nanometer, 280 nanometer, and also we can get in around 370 nanometer. Finally, we can get the 468 nanometer. Okay, this is we can attribute it to the pi to pi transition and also the n to pi transition of 458 nanometer. Okay, this is also we can confirm the aromatic in the sp2 carbon and also we can ask C11O, maybe C11S also it's getting from the surface of in carbon dots. On the other hand is photoluminescence, we can get the 463 nanometer. So is the blue line is 463 nanometer. And this one excitation spectra also 370 nanometers. So it is the highest intensities we can get around in 800 or 900 something. It is also in the same colorless solution after using the UV light. It is getting in the bright blue emission also we can see from this. So and also the prepared carbon dots, the photoluminescence excitation from 342 in 500 nanometer. The previous chapter we have to confirm the excitation dependent because of no changes in the stability of the carbon dots, but this carbon dots entirely different from this studies. So it will get in 340 nanometer to in 500 nanometer the excitation dependent wavelength. So another one is in morphological studies. So we can confirm from these studies the well dispersed in water without any aggregation. We can see the most of the particles is not aggregated particles, and also we can confirm the lattice print 0 to 2.3 also in previously also same on the sp2 carbon. From the above morphological evidences in statistical analysis, most of the 100 particles I have measured, and also the narrow size distribution in the 4 nanometer to 7 nanometer. The maximum average is the 5 nanometer of these carbon dots. The next one is the stability studies. We know very well about we have to optimize the carbon dots and also verify the stability of in nitrogen and sulfur carbon dots and pH levels, the sodium chloride of salt ionic concentration, and also the reaction time, the different reaction time and the storage stability. The most of these, this carbon dioxide maximum stable up to in salt ionic strength in 0 to 10 molar, the highly stable, and also in pH is maximum is neutral pHs. This is very important for in biological applications. So acidic or basic medium of stability is not good for in biological application. So here also we can get in around 5 to in 9 or 9 pH, up to 9 pH also we can get in the highest stability. And also in reaction time variation is no any changes, very less changes from this photoluminescence intensities. And also we have taken the photoluminescence intensities from day 1, and after 6 months the stability is 99% not stable, not changes anything from this carbon dioxide stabilities. Okay, the next one is the surface characterization. Mainly the functional group on the surface and nitrogen and sulfur grouped in carbon dots confirmed from this FTIR and XRD and Raman analysis. Also, the previous I explained the FTIR also in the maximum the hydroxyl and amine functional group also it's on the surface up in carbon dots. The SAR peaks up in 2,800 and something, and also in 1,360, and the sulfur S11O also in 1,385. This is very important for we can confirm from this in itself. Amino and hydroxyl and sulfur functional group also getting carbon dioxide, and also on another one is in XRD pattern. Previously I explained the same. I think almost in 25 and 26 theta, and we can get the T spacing in 0.34 nanometer. The first one is 0.34 nanometer, and another one is in around in 40 and 40 degree and 2 theta. It's also getting 2 lattice plane. So we can confirm from this carbon structure which is related to the amorphous carbon. We can confirm from the studies. The another one is in the gravities are the same as the Raman spectral analysis. We can get the two different range. In the first one is in 1,574 and another one is in 1,360, assigned to the two different bands in T and G bands. This also is the intensity is calculated from the 0.93. So we can confirm the graphitic structure. And also in the surface analysis, there are no any variation from this previous section and this section. Also we can get the same on sulfur double bond O, and also in another one is in carbon double bond O, and carbon also binding with the sulfur atoms. Finally the carbon atom. The mainly the nitrogen is two different pyridinic nitrogen. So the first one is in pyridine nitrogen 399 and also in 399.18. Pyrrolic nitrogen is getting from this, and also in nitrogen and carbon bond also appeared from this XPS analysis 401 electron volt. Okay. The next one is in selectivity of metal ions. The photoluminescence of carbon dots was applied to sensor applications in the presence of various metal ions. Previously, I used it in metal ions and biomolecules and nucleosides and sugar molecules also. Here I used only the metal ions. Almost in 20 different metal ions we can get in absorbance and fluorescence measurement. It also get in broadband sense 354 nanometer. It's also very broadband corresponding to the pi to pi transition, and also in sulfur thiol functional group also it's available. So, and another one is in hydroxyl and amine group also we can confirm from the studies after addition with the 3 micromolar various metal ions. 3 micromolar, maximum 3 micromolar various metal ions, it will get in 16 molecules, the silver molecules only we can get the highest one. And also we can confirm from this photoluminescence intensities in the 16 only the 90% is quenching from this original photoluminescence intensities. The another one except the Fe3 one. Fe3 also almost in around 15 to 20% photoluminescence intensity is getting. Okay, the green emission was observed from the studies. You can see from this, these are all the blue emissions, so that's why you cannot see clearly. So we can see the next slides. Yeah. This one is in sensitivity of silver ions. So we can confirm from this in photoluminescence in quantitative detection. The insert figure we can see blue emission and then add the silver ions. We can get the faint green emissions. Photoluminescence intensities from this. This one is in absence of silver metal, and also addition with different concentration 0 to 3 micromolar. You can get the 90% is quenching from this carbon dioxide. So we can confirm from the studies the same monomer flat using the absence and presence of intensities we can get from this part. Also in linear equation 0.99. So this complexation also we can get in 1:1 constant. So another one is in very important visible evidence. This one is in, you can see this video. So blue color emission is getting in less than 5 seconds. I think less than 5 seconds we can get this color changes. Please watch this video. The blue emission, and then we have to add the silver concentration. Yeah, green emission is happening. So next we have go to the further application from this carbon data and other things. So previously I used this one is photoluminescent ink. So here also I applied the bright blue and green color emission from this marker pen. So this both the aqua solution can be filled in commercially available in marker pen, directly used as a photoluminescence. Moreover, this photoluminescence is highly stable or at least 6 months under ambient conditions. Or we can tell about in room temperature also. The use of the both aqueous solution ink as anti-counterfeiting tools to characters we have to return and OU the same as in Professor Oyarli, the Yangnam University. So we can similar to the traditional photoluminescence, since bright blue and paint green photoluminescence emissions also observed in these cases. So this photoluminescence in bright blue and green is easily noticeable from this. Previously, we saw the video also. So owing to the photoluminescence intensities in both solution, we can use the photoluminescence ink. For next generation security ink also we can use this one. The another one is in the smartphone application. This is also a very important application. First time I used this application for my studies. We can calculate from this red and green and blue color values from the studies. With the addition of the first one is in blue emission, we can calculate from the circle of red circle from these values. We can get the captured using a smartphone camera. So the each color could be in represented by a point of the three-dimensional, three different values, red and green and blue values. And also we can get the 0 to 255 only. The first one is in, we can get 255, and the red one is in 8, very low, and also green is 202. And after addition with the silver ions, we can get the more green values also here, and also in red values also increases, and blue value is less compared to previously. The blue is very less. So here also we can confirm from this in emission color changes from these application studies. The next one is the same as the for biological imaging. The before optimization images we have to take in the cytotoxicity studies. It's also in high 25 to in 200 micromolar per ml. We can get the cytotoxicity almost above in 90%. And although we can apply it from the studies in carbon dioxide with the silver molecules. The first one is here we can see the different multicolor image. The first one is blue emission. Getting after addition with the silver ions, we can get the green emission also here. So we can use this both molecules aqueous solutions. We can use the biological applications in futures. Okay. So finally, this one the conclusion of these studies. So prepared the carbon nanotubes were comprehensively characterized using the UV visible, the same as in fluorescence spectroscopy and morphological studies and surface analysis characterization. So and also used in photosensitive probe for in maximum detection limit in 7.88 nanomolar, the range from 0 to 1 micromolar. As a new type of this photoluminescence ink, we can use the dispersion solution for photoluminescence ink can contribute to the next generation security technology. This is very important for information storage and etc. More interestingly, smartphone color picker software was used to identify the RGB color values from this both aqueous dispersal solution, which enable to the straightforward or this also in the instrument free of analysis. So the synthesis in carbon dot showed the low cytotoxicity for cellular imaging, and also this cells indicating the tracking of the intracellular silver ions. This paper also published in analytical methods and also in first author. This paper also published in recently 4 months back. So next one is the final topic is in multiple heteroatom doped in carbon dot photoluminescent carbon dot for in ratiometric detection with the ratiometric detection with mainly in mercury ions in cell imaging applications. Okay, this is my schematic diagram of shows the overview of my research work. Here also very interesting because we can get the blue emission and then add within the mercury ions in ratiometric detection, and then we can get the green emission and also intracellular tracking also we can found from these cell imaging studies. Okay, this one is the schematic diagram. Previously I explained like this, the same procedure and a little bit in modification because of here 2 different precursor I have used this one. The first one is methanione and another one is in phenylboronic acid. This is important for doped with in boron addition. Previously we have checked the nitrogen and sulfur only. This one is I have doped the coat of multiple heteroatom doped with phenylboronic acid. So we can confirm from this synthesis studies. So optical properties here previously I mentioned this the same like this. The absorbance value we can get from this in 425 nanometer, and also the emission is 450. This is a very less Stokes molecules. So we can confirm from this in 278 nanometer is the 5-to-5 transition, and also in there was in broad absorption peak. And this one is in broad absorption peaks in 425 nanometer due to the surface state of defects in nitrogen and sulfur, importantly in co-doped with in boron doped with molecules. So maximum excitation is emission of this one NSP carbon dots were observed in 425 nanometer and 452 nanometer. Okay, so the both the solutions which is in colorless the same as previously, and then we can get the blue emission. And another one is in photoluminescence studies, the water soluble this carbon particle, the excitation dependent feature, the same as in previously explained this one. So this also in a maximum wavelength 382 in 500 nanometer, and then we can get the uniform surface defect in with this size distribution also in maximum. So this we can confirm from this excitation dependent. We can use the possibility of multiple cell imaging or multiple multicolor imaging also we can apply. Okay, the next one is in the same as in morphological studies and FTIR and another characterization. So I have to move the next slide because of in the same results different doped materials. So I have to go in next results only. Yeah, this is very important in compared to previous studies because of this one is boron doped materials. So here we can confirm the more additional. We can get the survey spectrum from this one, the nitrogen and sulfur and boron and oxygen also we can get. Importantly, sorry. Okay, I'll continue with this one. The boron is provided the evidences from this existence of boron species. This one, this one is boron species. We can get the boron doped with the sulfur. So we can confirm from this XPS analysis. The boron also doped with the sulfur, and boron also doped with oxygen, and boron also doped with carbon material. So we can confirm from this XPS analysis, this is doped material 100% doped with carbon dot in another materials. Okay. The next one is in selectivity of metal ions. So this metal ions is we can measured from UV visible and photoluminescence spectroscopy. So they exhibited the maximum absorbance to 278 nanometer. This one is 278 nanometer, and also in we can get the broad absorption spectrum of 425 nanometer, and also this one is 450. This range, the 453 range is here. So after addition with the different metal ions, we didn't get any fluorescence intensity changes, very little and very low. And then addition with the mercury ions, we can get the highest intensities compared to threefold increases. We can see the clearly from this one, the 450 nanometer, and then addition with the mercury ion, it will getting in 496 nanometer. And also we can clearly see from this one, the blue emission addition with the mercury ions, it's green emission also we can got like this. Okay, the next and sensitivity of carbon dots, boron doped carbon dots with the other things. So here we can see clearly from this one, the 452 nanometer, this very low intensities only in squelching, and after different concentrations from this in 0 to in 30 micromolar, and we can get the photoluminescence intensities around 1200. We can confirm from this in quenching or enhancement intensities. We have to draw the plot. From this one is the maximum intensities appeared in 496 nanometer, and also we have calculated from this for in complexation, ratio complexation. This also we can get 0.99, and then we can get in maximum of 1:1 complexation. And also we used this in plot also. So Jobs plot also we can confirm from this in 0.5 mole fraction. We can confirm from another one confirmation from this one, and 1:1 ratio. Okay, the next one is the same as biological applications. Okay, the biological application, first we have to measure the cell cytotoxicity, and then we can get the maximum in 90% of cell cytotoxicity, and then we have to apply the carbon dot with the carbon dot metal complexation. The first one is in blue emissions, and then we can get the phase contrast and fluorescence and overlay images also. And we have to apply the two different ratio, two different wavelength ratio. The first one is we have to explain previously, this one 452 nanometer, and then we have to apply it in 503 nanometer. We can get two different color emission. Here also we can clearly see this one is the intracellular, more reactive with mercury ion with carbon dot materials. Okay, so the maximum is in the scale bar used in 50 micrometer, but we can clearly see from this cellular tracking is very important for biological application in future. Okay, this also is the most conclusion. The simple, cost effective and environmental friendly strategy was used for single step, the same as previously, without any doping material, also single step, and with the doping also single step material. So we can easily prepare in methanol sulfoxide with the phenyl boronic acid precursor. The term analysis we can confirm from this compared to previous two carbon dot. This is very less size we can get from this, because a doped material is always getting in, we can very less particle size. Moreover, we can confirm from the surface and the elemental composition from this FTR, XRD, and Raman analysis. And also the boron doped carbon dot demonstrated the ratiometric tan response from mercury ions. So photoluminescence color changes also in green emission with great selectivity and also great sensitivity over other metal ions. So the wide linear range from 0 to 30 micromolar, and the limit of reduction, maximum limit of reduction, and the limit of quantification also we can get in nanomolar range. So finally, the photoluminescent the boron doped proof was successfully applied to the ratiometric detection of mercury in fluorescence imaging applications using the CGT cells. So this paper also I have published in an analytical method in 2 months before. So last week we have attended one international conferences from Korean chemical societies. This is me, and this is my colleague, and this is my professor. We also attended this. The previously I explained this last final work. We have to get the excellent poster award from this KCS, Korean chemical societies. So this is this one also is very important for this one. So finally, the summary and conclusion. So we have to synthesize the photoluminescent carbon dot from small molecules through the single part hydrothermal assisted method only, without any solvent, without any precursor. So we can get carbon dot possesses the strong photoluminescence and excellent water solubility and good stability also. So we can get the morphology in average particle size less than 5 nanometer. Three different materials also we can get the less than 5 nanometer. So which is very important for in biological applications. So the carbon dot were successfully applied towards amino acids or other biomolecules and metal ion sensing. So photoluminescence we can use the multicolor live cell imaging. Moreover, the limit of detection and the rapid response time to merits of our carbon dot and photoluminescence probe. Okay. Furthermore, the new type of photoluminescent ink, this carbon dot solution, and also even in carbon dots with metal ion complexation solution, we can use the potential security ink for next generation technologies. So this also we can use the information storage and something. Okay, this carbon dot also very low toxicity and also excellent cell permeability. We can confirm from this last chapter. Easily we can track the cell molecules, the cell membranes from the carbon dot with the complexation molecules. So overall, the carbon dots can be used in biomolecules and metal ions for developing low-cost material and also selective biological and environmental detection of monitoring field. Okay. These slides I just show the recently published paper from these various journals in Journal of Molecular Liquids. This is sensor studies, and also I have published in organic synthesis with biocells and material. Actually, one of the track my work in sensor material. So our lab also established in lots of synthesis product, and then I have to study optimize all the materials, and like we have published in many paper from this organic chemistry with the sensor applications. So this also new Journal of Chemistry, and also in Taylor and Francis from this composite material. This also analytical method. Previously I showed this one also in elsewhere from this zinc oxide nanoparticles paper. This also in Taylor and Francis already reported this. This also my collaborated paper. This also organic letters from this maximum 2 and 3 organic letter papers, and this also very important career for my. This one is one of the co-author. We have published in chemical science and green chemistry also. This is my previous PhD field, continuous from these studies. I have published in first author microchemical journal. This is the sensor studies, and this also in ChemSystem and also in organic letter paper. Okay, this is my professor in first postdoc Professor Kui Fan-Wu, Department of Chemistry in National Sun Yat-sen University in Taiwan. This is my PhD mentor, Professor Tambusami Stalin, Department of Industrial Chemistry in Nalapa Universities. So these people's my collaborator from India and other regions also, China and other peoples. So finally, I have to acknowledge the title of this project is Study of Antiviral Drugs Used in Treat of COVID-19. I am the principal investigator. It will get the funding agencies from KRF and NRF. The period from the last year to up to 2024, it will average amount is 1 crore in 25 lakhs. So this work is supported by the National Research Foundation of Korea. This grant funded by the Korean government. So thank you very much for your attention. If any questions you can ask. Thank you.
Babar sir.
Thank you, Mohandas sir, for
Yeah,
your
thank
nice
you very much.
Thank you, Mohandas sir, for your nice presentation on topic small molecules derived photoluminescence carbon dots synthesis and application in biosensor. This is the nice presentation. Also, I congratulate to you. You have published one paper in green chemistry, which is
Yes,
having
thank you.
impact factor more than 10, and you have
Yes.
got one project. That project is also interesting.
Yeah, yes.
Now this topic is open for discussion.
Yeah, thank you.
Please, anyone have any question? Please ask.
So good morning. This is from Chintamani Dinesh. So I
Yeah,
had
yes.
one doubt related to the synthesis of carbon dot. you have, can you tell a little more about that? How can we synthesize, or can we start such type of work at our laboratories? What are the basic requirements for this? Thank you.
Sir, please.
Yeah, am I audible?
Yes, audible, but not clearly. Please tell me again, please. Sorry.
So during that, you have explained about the synthesis of the carbon dots, right? Can you elaborate little more about that? How can we synthesize in our laboratories, something like that?
Yes. First, we have to particular weight amount from these different precursors, and then we have to use the water solvent only. So here I use only for hydrothermal water solvent, not solvothermal method, only hydrothermal method. And then we have to mix it with in water solution. For gentle shaking, we can use the ultrasound bath sonization and something very few minutes, 5 minutes only enough. After that, we have to transfer the Teflon autoclave in maximum quantity is 50 ml, and then we can optimize the temperature is 200 or 180 and something, and then use the maximum 10 hours or 12 hours. After 12 hours, we have to cool down the autoclave, and then we can get in after 10 hours, we can remove out this material, and then we can use the centrifuge for remove the large particles. And also we have to it is attained in a large particle also is there. So further we have to dialysis use the dialysis membrane. So 1000 kDa or something, or 1500 kDa, we have to use the dialysis membrane, and then we can easily totally remove from the large particle from this carbon dot solution. Finally we have to maintain the 4 degrees Celsius, minus 4 degrees Celsius for in powder product, and then use the further application studies.
Very nice. It's a very nice and very interesting presentation. Also very, yeah, it's applications and all you have explained it very nice. Thank you.
Yeah, thank you very much.
Very useful.
Sir, I have one question.
Yeah, yes.
What is the meaning of cytotoxicity? Cytotoxicity.
Yeah, cytotoxicity, the cell viability.
Okay. I have another question. Addition of how addition to various cations affect the PL spectra of carbon nanodots?
Yeah, we have to measure maximum 2 ml quantity of an aqueous solution. Particularly, I have taken from this in pH 7.4 solution, and then we have to add is the very less amount at the microliter, the 5 microliter of in carbon dioxide solution, and we have to make in 25 microliter of different metal concentration. We have to addition one by one separately, and little second we can take immediately from this waste from this UV or whatever it is, fluorescence solution we can measure. Immediately we can get the fluorescence intensities. Maybe its carbon is quenching or enhancement also possible.
Okay. Thank you, sir. Thank you once again, Mohandas sir, for your nice presentation on the behalf of organizing committee of International E-Conference on recent trends in nanomaterials and its applications.
Okay.
Thank you very much.
Thank you very much.
Okay, thank you, Babar sir. Now I am grateful and thankful to Apasai Babar for being the chair. I am also grateful to Dr. Sonai Mohandas, Yangnam University, South Korea, for his excellent presentation in small molecules, derived photoluminescent carbon dots, its synthesis application, and in sensing and in bioimaging. Congratulations, Sonai Muthu sir, for your best and excellent presentation in your field. You did better work, and again congratulate that you have published in well-reputed and impact factor journals. Your articles are excellent. Thank you, sir. Thank you so much.
Thank you for your research. Thank you.
Thank you.
With this, I invite Professor Navle to conduct the coming session. Over to Professor Navle.
Okay, thank you. I am audible?
Yes, sure, you are audible.
Okay. Now welcome everyone for the session number 5 today. Okay, chairperson of this session is Dr. R.A. Bugad sir from Department of Physics, Sangola, Mahavidyalaya, Sangola. It is a great honor for me to introduce and welcome Today chairperson of the session and my best friend, Dr. R.A. Bugkar. Bugkar sir has completed his bachelor degree in physics with a distinction from KVP Magde, Pandharpur in 1990. In 1993, he has completed a master degree in physics with first class from Shivaji University, Kolhapur. He received a PhD degree in the field of ferrites from Shlok Ahilabai Holkar, Solapur University, Solapur in 2021. He has 30 years of teaching experience at Sangola Mahadale, Sangola. He has published 20 research articles in international journals and 10 in proceeding of international conferences with a citation 150 and H index of it is about 10. He has worked as a resource person in various conferences. Okay. With this short introduction, I hand over this session to Chairperson Dr. R.A. Bugkar sir. Now over to R.A. Bugkar sir.
Okay. Thank you, Professor Navli sir. I am audible.
Yes, yes.
Good morning, everybody. Welcome to fifth session of a international e-conference on recent trends in nanomaterials and its application 2022. I welcome all once again. Firstly, I am very much thankful to convener and organizing committee of this conference for giving opportunity for chairing this session. The research person of this session is Dr. M. Vasudeva Reddy from Yeongam University, South Korea. It's my great pleasure to introduce today's speaker. Dr. M. Vasudeva Reddy is currently working as International Research Assistant Professor, School of Chemical Engineering, Yeongam University, South Korea. He has completed his BS degree in 2006 and MS degree in 2009. He has awarded PhD degree in solar energy from Sri Venkateswara University, Tirupati, India in year 2014. He worked as a postdoc fellow in Yeongam University since 2014. He awarded senior research fellowship as well as junior research fellowship from University Grant Commission in research fellowship in science for meritorious student. He received a junior research fellowship from University for major research project. His area of research includes the fabrication of thin film, solar cell, hydrogen production, light emitting diodes, and photo detectors using inorganic materials, etc. In particular, his group is actively engaged in the research and development of tin sulfide selenides, antimony sulfide selenides, copper antimony sulfide selenides, copper zinc tin sulfide selenides, and copper indium gallium selenide, thin film solar cell, and LED devices. His group is credited with over 80 referred journal publication, over 100 conference presentation, and 1 registered patent in his discipline research. He has supervised over 2 MS and 5 PhD graduates. With this brief introduction of a great person, Dr. M. Devi, I would like to welcome to deliver his talk. Thank you very much. Thank you very much, sir. I request to Dr. M. Vasudeva Reddy to start his lecture.
Thank you so much, sir, for a generous introduction. I'm super excited to be here. And good morning to all of you. And today I am going to share some of my experience and about the abundant materials, as well as low cost, ultra low cost materials for solar cell applications. So my presentation contains the introduction about the solar cells and also the fundamentals of the solar cells and the research status in the solar cells. And finally, I will conclude my presentation. So here I will provide the information about the issues in the like current issues and the solutions for the current issues. So we are all know well that so the humans top 10 problems for the next 15 years are these. One is energy, water, food and environment and poverty and like other things. So particularly for the scientific community, the energy is a big challenge. So the human required the energy. So let us focus on the energy in the next couple of slides. So if you see here, the energy consumption, if you see from 1980 to 2050, it is almost increasing like exponential factor. So the world average energy consumption is predicted to reach in the soon almost like more than 30 watts per in 2050. So therefore, we should be a expertise in the energy conversion. Like first of all, we should know the well and energy whether we cannot create or destroy, but we can change the energy from one form to another form. So this aspect particularly is more important to understand. At the same time, we would like to utilize the natural sources like natural energy into our general requirement energy is more important. Currently, there are two energy requirements in the current society. One is a fuel and another one is electricity. Both we can use vice versa also. So particularly the light, from light to either electrical energy or light to for the chemical energy is interesting. These are the two major conversion fields. If you see that the before, most of the energy consumption comes from the coal, gases, and oil, and hydropower, biomass, nuclear, and other sources. But energy, like basically two types. One is renewable energy sources for the energy and non-renewable energy sources for energy. If you see this slide, most of the energy comes from the non-renewable energy sources. It makes more harder to the life in the future. Therefore, we should find the solution for this problem. So these are the more in detail information about the renewable energy sources and non-renewable energy sources. Renewable energy sources are wind, solar, and fuel lifetime, hydropower, and biomass energy. These are the renewable sources. Non-renewable sources are nuclear, natural gases, coal, and fossil fuel cells. These are the non-renewable energy sources. So yes, we need energy, but up to now, the way of the energy production is from non-renewable energy sources. It causes the many problems. If you see here now, the environment issues are the more as compared to the 1980s. So because of the more industrialization, let us do the next two slides. In this slide, let us get some idea about the environment. Like everyone is hearing about global warming and greenhouse effect. So these are the important things. Let us see. See, this is Earth, our home, the third planet from the sun. It's the only the planet to know have an atmosphere containing oxygen, motion of the water, its surface, and of course life. The greenhouse effect is a natural process and good thing for the human life. And the earth absorbs some of the energy it receives from the sun and radiates the rest back towards the space. However, certain gases in the atmosphere called the greenhouse gases CO2, H2O, and CH2 and nitrogen oxide and ozone and fluoride gases absorb some of the energy radiated from the earth and trap in the and that means it okay, the gases essentially act as a blanket making the earth's surface warmer. That means it is the natural warming of the Earth that results when gases in the atmosphere trap the heat from the sun that would otherwise escape from into the space. Greenhouse effect leads the human life safe with sufficient warmness in the earth because of the normal level of greenhouse gases. However, the modified lifestyle of the humans is creating our atmosphere hotter, more than like turbulent and more unpredictable. The gradual heating of the Earth's surface, oceans, and atmosphere is caused by the human activity, primarily the burning of fossil fuels that pumps the carbon dioxide, methane, and other greenhouse gases into the atmosphere. The abnormal greenhouse effect due to the increasing of the greenhouse gases resulting in the gradual heating of the Earth's surface is called the global warming. So green is due to the normal release of greenhouse gases, whereas global warming is due to the abnormal releasing of greenhouse gases due to the human activity. So here the burning coal and gas produces the carbon dioxide and nitrous oxide. The excess greenhouse gases and air pollution collect in the atmosphere and absorb the solar radiation causes the plant to get hotter. Our personal vehicles are also the major causes of the global warming. Collectively, cars and trucks and account for the nearly emitting around 24 pounds of the carbon dioxide and other global warming gases for every gallon of gas. Cutting down to forest and also the reasons for the global warming, farms apply these synthetic fertilizers to the crop. The fertilizers containing nitrogen chains of chemicals reactions generated the nitrous oxide and N2O, a greenhouse gas. This figure concludes the causes of abnormal releasing of the greenhouse gases. The global warming occurs due to these abnormal greenhouse gases, about 82% and 3% of gases, which are released from 28% from that 28 from the electrical generation. So if you see here, the naturally the cows also emit the CO2 that is sufficient for the normally. However, the modern society like the transport or electricity generation or industrialization causes the more CO2 emission. As a result, global warming is increasing. So we should find the alternative in the natural way for this. This figure, like the global warming, mainly 4 factors it affects: ocean, weather, food, and health. The average global temperature has increased by about 2 degrees per year over the past 100 years. According to the National Ocean and Atmospheric Administration, the global warming has led to an incredible increase in the Earth temperature. This has resulted in an increasing in the melting of the glacier, and which has led to the increasing the sea level, thus could have the devastating effect on the coastal regions. In 2020, it's estimated our ocean will be one of the 4 highest and threatening to the coastal flooding and including the entire Iceland nations and that world largest cities, including the New York and Mumbai and Sydney. The solutions for the global warming. So addressing the climate changes will require the many solutions. There are no magical bullet, yet nearly all the solutions exist today and many of them hygiene on the human change. And the way we have shifting the way we make the consumption and increasing in the wind and solar power for the home and industries and transport, minimize the global and developing the biofuels for organic waste using the recycling process to minimize the methane production from the waste. Develop the novel feed additives to cows to minimize the methane releasing from the next few years. And This slide provides the overview of the introduction up to now. So for leading our life, we need energy. That means we should produce the energy. During the energy production, we will use the solids, liquids, and gas conversion. As a result, excess releasing of the greenhouse gases, and that causes a global warming. So if we replace this greenhouse gas, like if we use the simple and from the renewable sources, we can reduce and the greenhouse effect for the normal life. Therefore, there are two solutions for this. Number one, we should produce electricity for the humans, sunlight, and also we should generate the hydrogen from the sunlight by using normal water. Therefore, we can solve the big issues for the society. So here I would like to provide the information about the fundamentals of the solar cell. The solar, first, before going to solar cell, I will provide briefly about the solar. Solar energy is a renewable energy, which means we will never run out of it. And solar energy is easy to generate. Solar panels are installed and are running at maximum efficiency. They will need a amount of the maintenance. Solar energy is non-polluting. Solar electricity power plants produce the zero emissions when they are up and running. Solar energy is infinite. We can get ultimate unlimited energy. So here there is information like information more about the solar energy. So it can produce like almost 23,000 terawatts. And if you see the other sources like wind and world energy, like biomass and hydrogen and others, it is all about like very small. And global energy requirement is 16 watts. If we are able to utilize out of 23,000 to 16 terawatts, that is sufficient for the human life. Here are some statistics about that consumption of the different energies. From the coal, we are utilizing 900 terawatts, and uranium we are using almost 90 terawatts, and oil 240 terawatts, and natural gases to 215 terawatts per year we are consuming. And here that cube provide the information about our annual requirement and also the how much the utilizing for our daily life. Still, we have large amount of solar energy for the human needs. So here I am going to provide some information how to utilize the solar energy for our lives. So the solar cell, which help convert the light energy to electricity. So solar cell is a photovoltaic device. It is an electrical device that solar energy directly into electricity by the photovoltaic effect. And from normal solar cell, PV system here provide the information about solar cells. It can have a group of solar cells. Solar cell is a single device. And when we add the number of solar cell, we call it as a solar module or panel or array. So here, the more information you can find on that website. Here I am showing the information and the basic principle of the solar cell. The solar cell is simply a PN junction diode in the absence of the light. In the presence of light, it converts the light into electricity. So this here the shown in the animation picture how that solar energy absorbed by this valence band of the active layer and how these electrons and holes are excited after absorbing the light. So yes, this is a general perspective for the specific aspect of solar cell. So here you can see that the IV characteristics of the solar cell. In the absence of light, you can see the diode nature of the IV character or JV characters. Whenever you illuminate it, the curves is shifting to the negative side. That means up or down side. So the difference between these two curves give the more importance, like information about the solar cell. The solar cell parameters, particularly one important parameter is the efficiency. We are all know that efficiency is only the matter. The remaining all is nothing in terms of the real application. So we should consider this efficiency. At the same time, we should achieve this efficiency with the lower cost. That I am going to show you the how can we generate the good efficiency with low cost process and materials. So here the another like other factors are fill factor and also the curve factor we say sometimes, and short circuit current density and open circuit voltage. These are the important characteristics. Whenever you completely disconnected, then the voltage we call it as open circuit voltage. Then this is short circuit current, the maximum current that we can obtain by short circuiting this device. And also, so we can find the squareness of the curve from the for the fill factor. So these are the main factor of the solar cell. Next, so here it provides the equation for this solar cell. So there, before I demonstrated theoretically, here it will provide the in terms of the equation. So the total current we can divide, like the number one is the dark and another one is a photon. So if you see that the photon current is important. I already explained before, like in the absence of light, it will work like a diode. In the presence of light, it will act as a solar cell. So we will consider, we just see the behavior of the device in the presence of photocurrent for the real application. In addition to, as explained before, there are two more other parameters: series resistance and shunt resistance. Series resistance means the resistance of the entire device, and shunt resistance is the shunt pass of the device. So for a solar cell application, a series resistance should be as much as lower. The shunt resistance should be almost infinity, as much as high. These are the two important things. And one more the important factor here, that we should achieve the fill factor as much as higher. That means practically possible 80% to 90%. And also we should achieve as much as the higher VOC and JAC. This VOC and JAC depends on your active material in the solar cell. Particularly the VOC depends on the band gap, and also current density also depends on the band gap of the material. So like here, I would like to provide the information about the solar cells, particularly thin film solar cell. The structure of thin film solar cell is first we have the glass substrate, and then we will coat one back contact, and then active absorber layer, and then buffer layer, and TCO, that means transparent conducting actor. Finally, we will deposit some contact. This is general thin film solar structure. But however, the right side, it's shown the simplified structure of the solar cell, PN. Silicon solar cell we usually prepare in this structure like a number figure 2. And the symbol of the solar cell, I think everyone know it, but still is useful for the beginners who are going to work or study about the solar cell. So these are the circuits of the solar cell. So before already I explained about, like, show the important factors for solar cell, this open circuit voltage, circuit current, and fill factor. So here simply, this is the voltage, like open circuit voltage is the voltage measured when the external circuit is open condition, or when there is no current flow in the circuit, external circuit. The short circuit current density it refers the current density produced when the two contacts are short circuited, or when there is zero voltage across the two contacts. This parameter is expressed in terms of the milliampere centimeter per centimeter square. For convenience and provide the easy comparison between the device fabricated with the varying contact areas. So the fill factor of the device is the ratio of the maximum power delivered by the device, and also the maximum open circuit voltage and like short circuit current. The conversion efficiency is defined as the output of the power by the input of the power. That input power is light, output is electricity. Next, this is the solar cell simplified like pipeline process. Like if you consider this above line as like water pipeline, there are some leaks. At near first is dark current. Dark current will like the junction near the in the absence of light, some current still flowing. Dark current is one leak point, and also shunt resistant is another leak point, and series resistant is the another leak point. There are three leak points. This dark current and shunt resistance and series resistance. Whoever able to block these holes, they can produce maximum efficiency. This is only the secret of the solar cell. So the initially the like we will generate the more electricity, but however the collection of the electricity at the end is the more important for any application. So this is the simple schematic experimental measurement process of the solar cell. So here the first we should have some solar simulator, and then we should measure one K3 source meter. We should get K3 source meter and the computer with supporting software. So here we will connect these ends to the solar cell, and we will see the performance of solar cell. This is my laboratory setup. Here downside red and black to connect the solar cell. These are again how to connect to the, and this is the place to we are going to keep our solar cell. This is the solar simulator that light will fall on the surface of the sample. When it falls, it will generate the electron and hole by using these two probes. We will collect, and it will measure automatically by using. This is an experimental process. So coming to the important, particularly research area. So this is current status of the various solar cells. CAGS, CDT, and silicon are more popular, and now perovskite solar cell also the similar level. They are showing like good efficiency, but still practically silicon, CDT, and CAGS is more popular. I think you can see everywhere around your living place the silicon solar cell, like black color solar cells. This is a research overview of the different solar cells. The most like prominent categories are silicon solar cells, inorganic thin film solar cells such as CDT, CAGS, organic dye and inorganic hybrid solar cells. That means perovskite solar cells. These are the main three categories. However, like if you see the crystalline solar cell, the efficiency gain is very slow, and also the high cost of the wafer price, and also high process temperature, which limit this technology for further utilization. And in the case of inorganic solar cell, the what we are using like the CAGS and CDTE, the efficiency gain is very slow and also expensive. Indium, gallium, and tellurium, and toxicity of cadmium and tellurium is also limit this performance. And the CAGS is a complex material system. That means it contains the number of like 4 elements. To control the process is more difficult. So in case of CDT, like selenium and also diffusion of cadmium is difficult to mass production. In case of the organic like perovskite solar cell, the efficiency is reasonable. However, the heat and moisture sensitivity are vulnerable, and long-term stability problems are there. So recognize the limitations of the exact materials. So needs to throw the development of breakthrough for the new material. The simplified here, if you see them, there are 4 factors to select any material for solar cell application. We should consider the material aspect. It should be low cost, ultra thin material should be also has a high good absorption coefficient, and the process should be the simple process. That means industrialization suitable process. The efficiency should be high as much as, and the stability also should be high. These are the 4 factors. If you see the already existing technologies, the problem of the some materials, like particularly new materials, are suffering with efficiency in terms of the process, or are cheaper. Technologies are suffering with the stabilities. For example, perovskite solar cell, the process and material aspect is cheaper. However, the stability is the issue. So in terms of the stabilities, inorganic materials are high stable, and we should find like the still we have the source, like the way to decrease the solar cell performance, like process and also the material selection. So still there is a strong need for low cost and high stability alternative material. So this is the selection criteria for any material for solar cell application. Not only for our solar cell, you can also apply the similar things for other application also. Number one, the material should be cheap and generic. Number two, the non-toxic and small element number. That means binary or a single element like a silicon or CDT, like simple elemental compounds are more suitable. And at the same time, the properties like electrical and optical properties are suitable for the light absorbing. And final thing is we should have long-term stability. These are the four important factors for selecting material. So this is simply you can refer that article and we can find the focus this side where we can get the low cost materials, and we should choose from these generic materials low cost. So particularly here I am going to show you the various alternative materials for the application, like iron based or based materials we can select. However, like copper based or the problems are like the stability and other issues is still existed in the case of copper based materials. And in case of iron based materials, still the purification and also the prepare the single phase or particular solar application is challenging. Therefore, it is so hard focus on the iron based materials or copper based materials. Therefore, the suitable materials are sulfosynthetic based materials or anti-based metal chalcogenates are promised for solar cell application. So what is the reason, like why should we focus on these two materials? The optical band gaps is around 1 to 1.6 electron volts, and actually theoretically ideally we need just 1.45 electron volt for application. And one is absorption 10 for 5 centimeter inverse. This is really high, and we need just 50 nanometers. The p-type conductivity is also important, and the resistivity of these layers is around 1 to 100 ohms per centimeter, and reasonably sufficient whole carrier concentration for 15 centimeter. The good minority carrier diffusion length and lifetime. The constituent elements are abundant in nature, not causes any health or environmental hazards, and the predicted light conversion efficiency of these metal sulfosilane for these materials. Information like the tin monosulfide is usually the orthorhombic and cubic structure, whereas is only in orthorhombic structure. So like the previous author, previous speaker, he provided more information about the different material characterizations and their analysis. So here in this section, like yes, the analysis is important. At the same time, the accurate analysis is more the important that I am going to emphasize here. Whenever we are going to utilize like particularly some formulas, calculations, we should use the accurate formulas. So here is, for example, provided some information to calculate the absorption coefficient. Of course, where the authors, they are using different formulas, they should mention the why they are using specific formula, and that makes the reasonable value for the absorption coefficient. For strongly, I recommended use either transmit and reflectance data or absorption alone. It will provide the reasonable value for the solar cell applications and for other researchers. And you can also, like by showing this absorption coefficient, if you see here, the most popular materials for solar cells are like CA, that means copper indium selenide or copper indium sulfide or gallium arsenide CDT. These are the materials. which have the sharp absorbed and over 10.5. That similarly tin monosulfide or antimony sulfoselenide, these two materials have the similar absorption coefficient. We can use almost 500 nanometer thickness of the material that's sufficient to produce the reasonably good efficiency around 30% practically. So here I'm going to provide, like I will provide the information how to fabricate the solar cell. We can make the solar cell. These are the steps. First, we should choose a good substrate for our application. Depends on our purpose. In general, in the research laboratories, glass substrate is a substrate, and then we will deposit by this sputtering. Sputtering is more the suitable technique for solar cell application. It's fast and provide for and good electrical properties. Next, observe. Yes, there are several to prepare the and chemical process. Even though we can go the ink coating from nanoparticles. However, still those technologies are suffering a number of steps increasing. But the promising methods are the process. The process is show the good efficiency and cell. Therefore, this process is interlace process kind of process to prepare the absorber layer. Then buffer layer, in general, buffer layer previously more of the others they use the chemical bath repulsion, but the perspective like ALE, MOCB are more promising to control the thickness of the buffer layer. And final is transparent conducting oxide. Here also we can use like solution process and also physical process. Physical process, particular sputtering is a good technique for preparing transparent conducting oxide. MOCVD is a more suitable technique to prepare them transparent conducting oxide. And finally, we will deposit the contacts as shown in the particular pattern. The pattern is also like the up to the author interest. So here, after completion of the device, we will measure as explained in the section 2. We can parameters as explained in the section 2. So this is the current status of the new solar cell, like at abundant low cost material solar cell status. If you see here, like CZTS is shown around 15%, and currently like antimony sulfate sulfoselenide is showing around 10%, and the tin sulfoselenide is showing around 5% efficiency. Still, there is, as like I mentioned, one disadvantage about the quaternary and other process. It makes like there are a number of materials to control the phase, and other things are critical. So we can go for up to ternaries like tin sulfoselenide or antimony sulfoselenide and iron sulfoselenide. These are the promising materials and the low cost materials. The process is suitable process is two-stage process. It consumes less energy and good as well as grain growth for solar cell application. But however, the drawback of these materials are the efficiency is still lower as compared to CAGS, silicon, and perovskite solar cell. Almost all these solar cells reached around 25 to 30% range. But these new materials are still struggling to overcome 15% efficiency. But we can improve the efficiency as shown like here by optimizing the process parameters, and we can control the structure, and as a result we can also control the properties, and we can achieve the reasonable performance. So the reason up to now the low performance are like the defects. So whenever we are able to control the defects by optimizing the process conditions, we are able to produce the high efficiency. Still, this kind of research is useful for the society. Number one, to reduce avoid the greenhouse effect. And yes, so currently the human society is facing two problems: energy generation from the renewable energy, and also like we are suffering like pollution, air pollution, the quality of the water also. To solve all these issues, yes, we can utilize the solar energy either to produce the hydrogen fuel or the solar. The solar cell is a simple device. It converts the light energy into electricity directly. We can utilize in the cars as well as in various applications. We can also store this energy by utilizing batteries. And the next thing is, yes, like still this technology is suffering with the two things, like particularly low cost material and efficiency problems. If someone like able to utilize these cheaper materials for the solar cell application, still this technology is competing and it is helpful to reduce the global warming and also like various other factors. So the current efficiencies of these new solar cells is around 15%. If we are able to increase the another 10%, so this technology is competitive with the already existing high efficiency technologies. So if you like anyone would like to improve the performance of this solar cell, so first thing is to process engineering. That when we engineer the process, as a result, we can control their structure and properties, and we can achieve the reasonable efficiency for the human need. Thank you.
Over to Gogol, sir.
Thank you, Dr. M. Vasudeva Reddy, sir. He delivered a very nice lecture. In his lecture, he explained on solar cell. Now the session is open for discussion. Now this session is open for discussion. If participants have any question, they can ask to you. Any question?
Yes, sir. Hello.
Yes, sir.
Hi. Okay. Okay.
Firstly, Dr. Reddy, sir.
Yes.
You have done very good work in the field of the solar cell, which
Thank
is
you so
required
much.
energy resource nowadays. Okay. Now, my one short question is, sir, what is the value of the efficiency, conversion efficiency of the solar cell?
Which solar cell, sir?
That you made by the using this material.
Oh, this like if you see this figure, these are the highest efficiency of the new materials, sir. So CZTS is currently around 15%, and antimony sulfide is around 10%, or copper tin sulfide materials around 7%. Tin sulfide is around 5%, and iron sulfide is also around like 4%. These are the current high efficiencies.
Okay, thank you, sir.
Thank you so much.
Question from participants? Any question from participants?
Hello, sir.
Yes, sir.
First of all, I congratulate you for your nice presentation. You have presented some basics of solar cells, and later on you have discussed your research related to solar cell. In your one of the slides, you have mentioned so many formulas of the coefficient of absorptions. So which one is the more usable, or which one is the more acceptable formula for to determine the coefficient of absorption? Yes,
yes, sir. Here, if you see here, like there is a reference also, so you can go that article. There's my article, and there I mentioned in details also. But here I will provide shortly. We can use only either absorbance or both the transmittance and absorbance. Transmittance and reflectance.
Yeah.
So if we use transmittance and reflectance, that formula is good, and particularly the actually we should, like the authors should mention like what formula they are using, why they are using, why they are limiting for some relaxations. So I think like a fifth is good enough for so if we follow the formula like 5, alpha is equal to 1 by D on 100 by the T percentage and R percentage. This is a good formula to calculate the absorption coefficient from the transmittance and reflectance. And if you see the 1 and 2, you can calculate from the absorbance of the data.
Yeah. Then another question is also related to this. Is it possible to calculate the absorption coefficient by the only reflectance data? Is it possible?
Yes, it's possible, but the accuracy may be not sure. Yes,
Yeah.
it's possible.
Yeah,
We
yeah,
have
yeah.
formula to calculate the. There are like several formulas and several things. That's why whenever you are comparing your band gap values with other people, sometimes so far, the reason is the method of calculation is also one factor.
Yeah,
And
yeah.
also, if you see the this optical band gap calculation, some people they can draw what they want from starting to ending.
Yes.
So
Yes.
there are some inappropriate graphs or calculations to explain the band gap. That's why still many people are struggling to say accurately what is how to evaluate the band gap and what formula is good enough for calculating the band gap.
Yeah, thank you, sir. Thank you.
Thank you so much for nice questions.
Thank you, Thomri sir. Now, any other question from participants? No question. So, any question? No question. So, I conclude this session. A very nice lecture delivered by the scientist Dr. M. Vasudeva Reddy on the topic solar cell. In this, in his lecture, he explained a causes of a global warming due to the conventional due to the uses of a conventional energy sources and a solution of this global warming by using a solar cell. In his solar cell, he explained it's a preparation of this solar cell by using or a fabrication of a solar cell as well as the preparation of a solar cell, which material is useful. For this purpose, he used a sulfo-selenide material with different substances, and it's how efficiency of a solar cell that can be increased by using sulfo-selenide solar cell. And now this is the most useful lecture. It is for a student as well as a researcher. Now this information given about the solar cell by Dr. M. Vasudeva Reddy is useful for our student. He explained fill factor, efficiency. These are practical for our student. Now I would like to conclude this session. Now I am very much thankful and to participants for their patientful listening. Thank you very much, sir. Thank you. Now I hand over this session Professor Nule, sir.
Okay, thank you, sir. I am very thankful to Dr. R.A. Bugad sir from Sangola College, Sangola for chairing this session very nicely. And also I am thankful to the resource person of this session, Dr. Reddy from South Korea. Okay, thank you once again. Now I hand over to this session to Dr. Dasari, sir.
Okay, thank you, sir. I am grateful and thankful to Dr. Bugad sir for conducting nice session. I am thankful to Vasudev Reddy for his excellent presentation on earth abundant and ultra low cost solar cells. I am thankful to Professor Navle sir for your excellent presentation. And now I invite and welcome Professor R.S. Gaikwad and Dr. Swati Patil to conduct the session. Over to you, Professor R.S. Gaikwad.
Okay, thank you, Dasari sir. This is the last about one session, that is sixth session. I request to Dr. S.D. Patil as a chairperson. Dr. S.D. Patil is from Pratap Singh Moite Patil Mahavidyalaya, Karmala. His educational qualification is MSc PhD. BSc from Vidyan Mahavidyalaya Sangola, that is Shivaji University, Kolhapur in 1991. MSc from Solapur University, Solapur, 2007. He has done PhD from Bamu University, Aurangabad in 2011. He is working as a lecturer for physics, Department of Physics, Pratap Moite Mahavidyalaya, Karmala, from last 10 years. He has published a number of papers in national, international journals. It is 27 papers. And he also published in conference proceeding, that is the 9 papers. Participation in seminar, workshop, conference, that is 17. He has published 27 papers in international, national journals, having high impact factors, having high citations. Okay, I request to Professor Swati Patil to conduct this session as a chairperson. Thank you very much.
Okay, thank you. Thank you, sir. It is my pleasure, a great pleasure to chair poster session of International E-Conference on recent trends in nanomaterials and its applications 2022, organized by Department of Physics, Vigyan Mahavidyalaya, Sangola, with collaboration of IQAC. I am immensely happy to express my gratefulness of my college, where did I take my education. I am thankful to organizer of this conference for giving me such an opportunity to chair the session. I welcome you all for the 6th session of this international conference. The efforts are taken by the organizer and resource persons are very, very great extent. Now I would like to invite first participant of the conference to present the poster on antimicrobial activity of cadmium sulfide quantum dots mediated by leaves by T.R. Devri. I invite T.R. Devri present his poster. Over, Devri. I invite T.R. Devri to present his poster.
Devre, is it audible to you?
He has not
Next,
read. Can I call sir next?
yes, call me.
Okay. Next participant is, now I would like to invite second participant of the poster presentation. He will present on copper oxide nanoparticles mediated by coffee powder extract and inhibitor of Candida albicans biofilm by P.G. Jadhav. I call P.G. Jadhav to present his poster.
Hello, ma'am. Am I audible?
Yes.
Yes, sir.
Ma'am, am I audible?
Yes,
Yes,
Yes.
sir.
please proceed.
Okay. Yeah, okay. Hello, everyone. Myself, Praful Jadhav from KCW College. I will discuss about copper oxide particles. My topic is copper oxide nanoparticles mediated by coffee powder extract and inhibitor of Candida albicans. I have done this better of AP governance and this is my poster. I will discuss about so today this is for the well-being of and sustainment of environment. The green synthesis tries to a certain synthesis process that reduce the harmful chemical reactions and improve the efficiency and provide good quality of production in economically manner. In various nanomaterials, metal oxide more interest with a wide range of properties such as optical, chemical, electronic, mechanical, and magnetic properties. And in that, copper oxide nanoparticles have various applications, such as solar cells, biodiesel, photocatalysis, water pollutant removal, low cost and non-toxicity, antibacterial, antioxidant, and antibiofilm. Now, here in the present study, we present the green synthesis of copper oxide nanoparticles using coffee powder extract, and then the synthesized copper oxide nanoparticles were characterized using different techniques like XRD, that is X-ray diffraction, then UV visual spectroscopy, then FTIR, that is Fourier transform infrared spectroscopy, FASM, field emission scanning electron microscopy, and then the nanoparticles, the copper oxide nanoparticles were further treated for doing anti-biofilm activity. Here I will discuss one by one. Before that, this is a schematic which shows the formation of nanoparticles, that is copper oxide nanoparticles. This is a coffee powder. Here it is an extract. This is a copper nitrate. Simply this was added in extract, and the further container was moved to sand bath. Then further doing the continuous stirring process for about 12 hours. This green color powder was obtained, and then the further doing calcination process, these nanoparticles were formed. Then, as I told, these copper nanoparticles were further characterized using like this is a XRD graph which shows different peak positions. This XRD pattern shows a face-centered cubic crystal structure and with an average particle size of about 15 nanometer. And then here it is a UV visual spectroscopy. This shows the absorption range between 265 to 285 nanometer, and that confirms the formation of copper oxide nanoparticles. Then this is the FTIR of that coffee powder, and this is the FTIR of copper oxide nanoparticles. And this graph shows a strong band at 422 centimeter inverse, which can be attributed to the vibration of copper oxide. Then this is the FASM results. I will explain one by one. These are the FASM images which I have got at different ranges, like about at 50 micrometer, 10 meter, 5 meter, then 4 meter. This is about 5 nanometer, and so on. Then this is a energy dispersive X-ray spectroscopy, that is EDS plot. This indicates the presence of two elements, that is copper and oxide, without any impurity to it. Then this is the elemental mapping of copper oxide nanoparticles. Then, as I told, the nanoparticles, copper oxide nanoparticles were further treated for doing anti-biofilm activity. Here the nanoparticles were worked as an inhibitor that inhibits the growth of Candida albicans, which is a fungi. This left image shows the percentage inhibition of biofilm, and this right image shows the optical microscope image of inhibition. And here it is a plot of it, which is the percentage biofilm inhibition. Then these are the conclusions. XRD diffraction shows this, that XRD plot shows the face-centered cubic crystal structure with an average particle size of 15 nanometer. And UV visual reveals the absorption range in the range between 265 to 285 nanometer. That confirms the formation of copper oxide nanoparticles. Then FTR shows a strong band at 422 centimeter inverse, which can be attributed to the vibration of copper oxide. Then FASM along with EDX, it indicates the presence of two elements, that is copper and oxide elements with an impurity. And then the copper oxide nanoparticles were used to inhibit or an impeder of the candida albicans biofilm, and it shows about 65% inhibition demonstrated by percent inhibition and optical microscope images. Lastly, I would like to thank to our principal and head of department for giving instrumental facilities to carry out my research work. And also I would like to thank the principal Dr. Latesh Nikam sir from Sangli College for providing the characterization facility. Thank you, everyone.
Thank you, Jadhav. It's
Thank you, ma'am.
nice presentation. Session is over for group discussion. Audience can ask questions. Anyone have a question? Please ask. Okay, no question. Nice presentation once again.
Yeah, thank you, ma'am.
Thank you for presentation.
Hello.
Yes. Yes, ask. Yes, ask question. Okay.
Continue.
I will continue. Thank you for presentation. Now I call next participant. He will present on high stability MNO method for supercapacitor application by Onkar Pori. I invite Onkar Pori for presentation.
Thank you so much, madam. Am I audible?
Yes.
Is it my screen is visible?
Yes, visible.
Yes.
Okay, proceed.
Okay. Thank you, madam.
But you are not visible. The screen is visible.
Bandwidth problem is there, so I mute my video.
Okay, okay. Continue.
Okay. First of all, I would like to thank you for this international conference for giving me an opportunity to present my research work through this virtual platform. The title of my presentation is High Stability Mn2O3 MnCO3 Microcubes Synthesized by Hydrothermal Method for Supercapacitor Application. The accelerating energy demand and energy consumption directly and indirectly leads to deficiency of fossil fuels and environmental problems such as various types of pollution, global warming, etc. To counter this problem, it is very essential to harvest energy from inexhaustible sources such as solar, tide, wind, etc. Such environmental issues have suggested the utilization of not only alternative clean energies, but also more advanced energy storage devices. Among the various energy storage devices, supercapacitor is one of the most important candidate because of its silent features such as fast charging discharging process, high energy density, high power density, as well as long cyclic lifetime. Then materials and methods. As mentioned in this figure, we have utilized hydrothermal method for the synthesis of Mn2O3, MnCO3 microcubes. Here we used MnSO4 as a precursor, then urea, then Na2SO4. Here we used stainless steel substrate as a current. First of all, here the hydrothermal parameters used for synthesis of this material is reaction time 120 degrees, reaction time was 600, reaction temperature was 120 degrees Celsius, and after getting that film, we varied calcination temperature from 350 degrees Celsius to 500 degrees Celsius. Then the prepared parameters were characterized by characterization like XRD, FTIR, then morphology by SEM. Figure A shows the XRD patterns of as synthesized film. Initially, when calcination temperature was 350 degrees Celsius, the obtained material was MnCO3 only. But when as calcination temperature increases from 350 degrees Celsius to 500 degrees Celsius, the partial decomposition occurs and Mn2O3 and MnCO3 was obtained. And this was confirmed by XRD patterns. The XRD pattern shows Mn2O3, which is corresponding to the Jesse-Perez card number 411442, and MnCO3 corresponding to the 441472. Then figure B shows the FTIR study. FTIR study also confirms the formation of Mn2O3 and MnCO3. Then figure C shows the SEM image of as prepared sample. Here we can see the prepared sample shows microcube-like structure. Initially, when calcination temperature was 350 degrees Celsius, the microcubes covered with nanocubes was observed. But as calcination temperature increases, the nanocubes self-assembled and they self-assembled merge into one another to form a microcubes. Then the result and discussion. The as prepared samples were characterized by electrochemical supercapacitor study. Figure A shows the electrochemical impedance spectroscopy study of as prepared samples. Here we can see that figure A shows the Nyquist plot of as prepared sample. The estimated parameter, that is solution resistance, charge transfer resistance from this graph are mentioned in this table. Then figure B shows the cyclic voltammetric curves of as prepared samples. Figure C shows the galvanostatic charge discharge of as prepared sample. Then the estimated parameter, estimated specific capacitance as a function of current density is mentioned in figure D. Then energy density and power density is mentioned in figure E. In case of supercapacitor, cyclic stability is one of the most important aspects. Here, the optimized sample shows about 111.1% cyclic stability over 10,000 cycles. And this better cyclic stability may be due to the structural changes after the cyclic stability. So here we can see that the microcube surface was plane, and this SEM image is taken before the cyclic stability. But after cyclic stability, here we can observe the SEM image, and the plane surface get converted into flex-like surface, and that flex-like surface will enhance the cyclic stability of as prepared samples. Then these are the conclusions. Mn2O3, MnCO3 microcubes are prepared by using hydrothermal method on stainless steel substrate as a current collector by binder-free approach. Then Mn2O3, MnCO3 microcubes with reaction time 6 hours, reaction temperature 120 degrees Celsius, and calcination temperature 400 degrees Celsius exhibited 260 million current density. And their optimized sample will show excellent capacity retention, about 111.1% after 10,000 cycles. Then acknowledgement. We are thankful to Department of Science and Technology, Science and Engineering Research Board for financial support. And these are the references. Thank you so much.
Thank you, Omkar Kore, for a nice presentation. You have to choose a very nice topic. Okay. This session is open for discussion. Ask anyone a question. Anyone have a question? Please.
Shivani, please unmute yourself and ask the question.
Mr. Omkar, would you please explain why have you used steel substrate?
Hello.
Hello, am I audible?
Yes, yes.
Hello, Omkar.
Or Kore.
Hello, Mr. Omkar.
I think there is a connectivity issue.
Yes, yes, it's okay, sir. It's fine. Thank you.
Okay, we have noted your question.
Okay.
Okay, I conclude here, and I call next participant for his presentation on growth study on anti-replacement of zinc by MN into CZTS thin films. I invite him to present the poster. Mr. Yadav. I invite next candidate Yadav for presentation.
Yes, madam.
फॉल ಕೂಡ ಇದೆ ए स्क्रीन शेअर नसते तू जिथं आहे तिथं ओपन करता मध्ये दिसते
Yadav, share your screen.
हां बोल
You have network problem? Are you ready? Sir, can I proceed next candidate?
Continue, madam.
Okay. Next one, the last participant of the session is Ankita Bagal. She will present on thin films of CZTS grown wire replacement of zinc by manganese using Silar method. I invite Ankita Bagal to present his presentation. I call Ankita Bagal.
Yes, ma'am.
Share your screen.
Sorry, ma'am. There are some technical issues.
Are you?
Give me some minutes.
Some minutes.
Yes, ma'am. इतक्या वेळ कधीपासून सांगत
Start your screen sharing.
Ready? Are you ready?
No, ma'am.
Patil madam, continue.
Can I give the chance to next person?
Yes, continue, madam.
Okay. I will like to invite.
Hello. Hello.
Yes.
Hello. Excuse me, madam. This is Dr.
Yes.
Gawande from Nasik,
Yes.
KSKW College. So one of
Okay.
he was the first presenter for this session, but due to some technical reason, he was not able to start his presentation. But now he is ready. Is it possible to start?
Yes, yes, sir.
Okay.
Hello, good afternoon, ma'am.
Yes.
I am Tushar Rajendra Devre. I am from KSKW College. I am here to explain the antibacterial activity of created by.
Yes.
Mediated Aglamarvus use. Can I share my screen? Can I share my screen, ma'am?
Yes, yes.
This is my overall poster, ma'am. But I am taking the PPT to understand the all over poster. Now, in recent years, the green root is very attractive method for the researcher, and the development of green based synthesis of nanoparticles has been regarded as a novel and alternative method because of their stability and their biocompatibility.
Yes.
Hello, ma'am. Yes,
Ah,
ma'am.
yes.
Quantum dots are very small in range, up to 2 to 10 nanometer, ma'am. And I use Agile marvelous, means a bell leaf used as a capping agent. I taking a several characterization for that XRD at CUK alpha at the radiation of CUK alpha 1.54 Armstrong, and FESCM UV visible spectroscopy, and FTIRMM for both Agile marvelous and also the synthesized CDS quantum dots. In the schematics, we can see that, ma'am. I take the Agile marvelous and then I prepare extract. The extract was 5 ml, and I add 90 ml of distilled water in the proceeding of 0.2 gram of cadmium chloride was added, and then I stirred for 100. I stirred at 100 degrees Celsius for 2 hours, and also after that I also add 0.78 gram of sodium sulfide, and then I stirred up to 2 hours, and the final yellow color product was filtered and centrifuged and dry at room temperature, and the final powder was used for further characterizations. My first characterization is, ma'am, X-ray diffraction. From X-ray diffraction, we can analyze the crystal structure, nanoparticle size, interplanar spacing, and the XRD peak was found to be 26.9 degree, 46.78, and 53.5 respectively. And then by using the device sharer method, which is K alpha, D is equal to K alpha divided by beta cos theta, sorry, D cos theta. Beta is, ma'am, full width half maximum. I determine the average particle size, which is 4 nanometer, ma'am. And this is 4 nanometer, ma'am. My second characterization was Fourier transformer infrared spectroscopy, ma'am. In this characterization, I am taking two FTM, one Agile marvelous and other Agile marvelous loose mediated by and cadmium CDS quantum dots, CDM quantum dots. FTN analysis was determined to FTN analysis was carried out to determine the possible biomolecules or functional groups which is responsible for stabilization of synthesized CDM quantum dots. In figure, we say that we can show that we can see that in figure we can see that the main peaks are 340.71 inverse for Agile extract, Agile marvelous extract, and 3269.34 for synthesized series quantum dots, and both the shift between this point Agile marvelous to series quantum dots, we can say that it may be possibility to these peaks are this peak shift implicates the involvement in the formation of cadmium sulfide, and due to the various functional groups from the wavelength, we can see the carboxylic, hydroxylic, and amide groups from Agile marvelous use. My third characterization, ma'am, is field emission scanning electron microscope. There are various ranges. I am taking the series nanoparticles at various ranges. The synthesized product of series quantum dots characterized by using FASM technique, which is used for study the surface morphology. Series quantum dots show particularly are nearly spherical in shape. and morphology with slight agglomeration. We can clearly see. My fourth characterization is, ma'am, UV visible spectroscopy. UV visible spectrum is often used to study the effect of particle size and optical property. The absorption wavelength range for synthesized quantum dots was 200 to 600 nanometer, and it is well it is well known that UV visible absorption peak of serious bulk material is about 520 nanometer. But my serious my UV my UV spectroscopy maximum wavelength occurred at 440 nanometer, and we conclude the band gap 2.78 electron volt by Einstein energy equation, or E is equal to hc upon lambda, where h is the Planck constant, c is the speed of light, and lambda is the wavelength we used. Ma'am, antibacterial activity. I perform the antibacterial activity for an application to Mercedes quantum dots. We perform the antibacterial test to inhibit the growth of Staphylococcus aureus bacteria by cell diffusion method. Is shown in figure. By using well diffusion method. The Mercedes quantum dots penetrate through the cell wall and enters the bacterial cell, produce the reactive oxygen species ROS, and the generated ROS targeted intercellular constituents such as DNA, mitochondria, and protein. And the reaction of Mercedes quantum dots with intercellular constituents will produce a higher ROS to induces strong oxidative stress in the cell. DNA, mitochondria, and protein later degrade as a consequence of this oxidative state environment, and finally destroy the bacterial stain. And the image C show that, ma'am, this image show that the Mercedes quantum dots inhibits the Staphylococcus aureus bacteria and give 36 mm zone. Conclusion, ma'am. I concluded that, ma'am, I concluded that the green synthesis of serious particles resemble the results of chemically synthesized particles. This proves that serious particles can be synthesized without using toxic chemicals and costly capping agent. And the series shows the values like interplanetary distance by XRD, particle size by XRD, energy band gap by UV, functional group by FTIR, surface morphology by FSM are identical with the ICS, which are in bulk. And the prepared serious energy band gap of the serious nanoparticles was estimated 2.78 electron volt, where the ideal was 2.4, the which is large than bulk due to the quantum confinement. The prepared nanoparticles can be directly in the biosystem because of their excellent biocompatibility. The synthesis series quantum dots found to be inhibit Staphylococcus activity.
Okay, thank you. Thank you, sir, for a nice presentation. The limit I will conclude, and I would now like to invite next presenter Ankit Pagal to present his presentation. Thin films of CS growth replacement of zinc by manganese using Ankita, present your presentation. Are you ready?
Ankita Bagala, are you presenting? Okay, ma'am, call to honor.
Can I call
Yes,
next?
sir.
Yes. Are you ready for presentation?
Yes, ma'am.
Share your screen.
एकदा लॉगिन करून लॉगिन नाव होती
Patil ma'am, please
yes.
continue the session.
Okay.
It is impossible for us to do more time. Please continue.
Okay, I conclude here this session. Thank you for the organizer to give me a chance to chair a session of session. The organizer gives such efforts to organize such nice conference. Very great extent. In all, conference is very excellent. I thank to organizer for giving me a chance. Now I hand over the Mr. Person.
Yes, thank you, madam, for
Yes.
chairing the nice session. Again, thank you.
Okay, thank you.
Now I request to next session coordinator and hand over this session to next person.
Thank you, sir. Now I am grateful and thankful for conducting nice session. I am thankful to Swati Patil for conducting the session. Thanks, Mr. Gaikwad and Swati Patil to conduct the sessions. I am also thankful to Prabhu Madhav, Omkar and Tushar for your nice presentations. I am going to hand over this session to Dr. Kumari. Over to Dr. Kumari.
Thank you, sir. Department of Physics, in collaboration with IQAC, has organized an international e-conference on recent trends in nanomaterials and its applications, that is RTNA 2022. We are in the last session of the conference, that is valedictory function. The chief guest of a valedictory function is Dr. Anamika Kadam madam. President is acting principal Dr. R.A. Phule sir. I request convener Dr. S.S. Dasade for conference overview and introduction about chief guest of valedictory function, Dr. Anamika Kadam madam. So I request Dr. S.S. Dasade sir. It's over to you.
Thank you, Domre sir. President of valedictory function, acting principal of the college, Dr. R.A. Phule. Chief guest of valedictory function, Dr. Anamika. All the participants. Department of Physics, in collaboration with Internal Quality Assurance Cell, organizes an international e-conference on recent trends in nanomaterials and its applications 2022. The conference functions with the first session as an inaugural session. Dr. Aniket Deshmukh is the president of this function. He expressed about when the dimensions of substance become too small, their physical and chemical property goes on changing, and they can be useful for the society. He also expressed special importance of very fine particles of the substance in the field of medicines. Professor Seen was the keynote speaker of the conference. In his talk, he guided how the physical and chemical properties of microscopic wires are used in manufacture of devices, as well as the use of wires made for the microscopic particles in solar energy to increase the working capacity of the devices. The second session of the conference was chaired by Dr. S.B. Kulkarni, and the resource person was Dr. Raj Shekhar from Yangnam University, Korea. In his talk, he expressed the composition of materials made up of very fine particles, improving their quality if they are composed of the components with different elements, and the equipment made from such materials. For example, supercapacitor is made for higher capacity. The third session of the conference was very interesting. It was oral presentation of the research scholars. This session is chaired by Dr. Sagar Mane from South Korea. He conducted this session nicely, and due to the time limit, only 2 of the research scholars have presented their research articles excellently and very betterly. Now here, it is the second day of the conference. The fourth session of the conference is chaired by Dr. Appasai Babar, and the resource person is Dr. Sonai Mutu Mohandas from Yangnam University, South Korea. He presented his talk on small molecules, derived photoluminescent carbon dots, and its applications synthesis in sensing and bioimaging. Session 5th is chaired by Dr. R.A. Bugat, and resource person is Vasudev Reddy sir. He is again from Yangnam University, South Korea. He talked about earth abundant and ultra low cost solar cells. Now my special thanks goes to Dr. Sagar Mane for taking more and more efforts in success of this international event. He is one of the prominent alumni from our this physics department. Now I would like to conclude the conference overview by the introduction of Dr. Anamika Kadam. It is my great pleasure to introduce Dr. Anamika. She did MSc from Shivaji University, Kolhapur, and PhD from Bharati Vidyapith University. She is Associate Professor in Department of Physics, the Institute of Science, Dr. Homi Bhabha State University, Mumbai. She did research on electrochromic properties of nickel oxide conjugated polymers thin films. Dr. Anamika Kadam is honored by OCA Research Fellowship from Sakar India Foundation during 18 and 19. She is honored by Young Scientist Fellowship DST SERB in year 2014 to 17. She received first prize in poster presentation of National Conference on Emerging Trends in Engineering, Technology and Architecture 2012. She received first prize in paper presentation of National Conference on Emerging Trends in Engineering, Technology and again Architecture in 2013. She got third prize in poster paper presentation of CRET 2009. She got honored by second prize in poster presentation of MSDLA 2015. Dr. Anamika, she published 28 research articles in well-reputed international journals, 20 research articles in national journals and proceedings. She has presented 27 research papers in national and international conferences. Her article got cited 635 times. Her H index is 11 and I-10 index is 13. With this, I welcome Dr. Anamika as a chief guest of the valedictory function of this international conference. Thank you. Thank you so much. Over to Dr. Thomre.
Okay. Thank you, sir, for sharing overview and introduction about chief guest. Now, participants are requested to share your views about RTNA 2022 as a feedback. I request Mr. Onkar Pore to share your views as a feedback. Mr. Onkar Pore.
Thank you, Thomre, sir. Am I audible, sir?
Yes, yes.
Okay. First of all, I would like to thank you, organizers, for giving me an opportunity to express my feedback.
I think due to internet connectivity, there is a problem between Onkar Pore and us. So I request one more participant, Dr. Dinesh CM, to share your views about RTNA 2022 as a feedback. Dr. Dinesh CM.
To delegate and for international conference on recent trends in national nanomaterial applications. So for details, what I felt here that this could be an right to have a communication. And actually, I had a plan to this workshop, this conference for our, but unfortunately, this is an though it is in a college, so this college is doing a wonderful job that national conferences, which is a very good development, and I hear that this is one of my who are there, educated and we don't have an be a but all the resource persons who are mostly from Korea, and that especially talks are having high very advanced, and this was my observation. So oral present accepting our paper, and such events from this college, and even your observation, I had a plan that if we have some collaboration, then also such type of a event in our college. So I request your help in having such type of. I request for other colleges also. So thank you. This was my wish, and thank you, sir.
Thank you, sir, for sharing your views. Now I request our resource person, Dr. Anamika Kadam Madam, for valedictory address. Dr. Anamika Kadam Madam, it's over to you.
Yes, thank you.
Yes.
Yes, madam.
This conference, Saturday, sir, all the faculties of Nano-Materials, distinguished participants, ladies and gentlemen. So, thank you, all of you, for inviting me. Yes, for valedictory session speech. Like the map of change. Of course, this is the last conference. This is not change. This may be the start of someone's life. I have seen the program schedule of the conference with eminence from national, international level. Truly, it was a delightful food of knowledge. I'm sure that you had 2 days of very productive discussion with a distinguished gathering of participants. Some minds might have got inspired. Some might have got tricks to conduct their research by applying new approaches. After all, it's sharing of knowledge. Inspiring the youth is an important task because we Indian people are still thinking about nanotechnology. But, dear friends, American country is moving towards the femto technology. Femto technology, that means 10 to minus 15 meter. What a smaller thing, she. That means for reaching such a smaller level, so much of hard work required. And young generation, everyone has provided with some great potential within them. So bring that potential into practice. Identify the limits in every application and try to improve them with the quality research. Wherever you are moving, observe the surrounding, find limitations, work on it. So think accordingly about how will you give benefit to the society with your great potential knowledge. Read newspapers for awareness. It also gives the research ideas. These days you can observe that coal is vanishing, scarcity in semiconductor industries, need for hydrogen storage devices, pollution absorption, and so for doing this research. Why I'm talking about this research? Because research is valuable for daily uses. It's a tool for building knowledge and facilitating learning. It's a means to understand issues and increase public awareness. It helps it allows us to develop life, support opportunities, love, and confidence in reading, it provides nourishment and exercise for the mind. So much more things are there to say. But dear friends, I have certain limitations. So with this research thought, I can end my talk. And once again, I'm very thankful to the principal and convener for giving me this chance. And finally, I congratulate all the faculty of Vignan Mahavidyalaya Sangola for taking great efforts to make this conference RTNA 2022 a great success, because some of the time reaching the place of the conference is little difficult, and you all are giving this, taking lots of effort to make this event a great success, getting chances to the residing places, cause very fruitful for the participants of colleges, the participants from colleges, is very important. It's a great social work that college is doing. So I again congratulate and thank you to one and all. Thank you all.
Thank you, madam. Thank you very much. Madam has extremely remarks on the various key aspects of the nanomaterials. So thank you, madam. Now I request our honorable acting principal and president of valedictory function, Dr. R.A. Phule sir, for his presidential remark. Dr. R.A. Phule sir.
Good afternoon to all of you, respected delegates present on the Zoom meeting platform, IQAC coordinator and convener, Dr. S.S. Lasade sir, organizing secretary, Dr. J.V. Thumbre sir, State Department of Physics, Mr. D.B. Navle sir, Chief Guest of Electric Functions, Dr. Anamika, chairpersons, students, active participant, faculty, staff members of for organizing this event. Yesterday conference was the inaugural session, and some found that nano-size material has special features. Chief guest of the valedictory function, Dr. Anamika Kadam madam, also maintained that the importance of the nanomaterial for the performance of devices. I am working in field of geography. I know various physical parameters like temperature, wind speeds, etc., change climate. Similarly, from the technical sessions, I understand that the properties of the nanomaterial depends upon the systematic parameters. Department of Physics is always organized such events for the overall the Department of Students. The Department of Physics had made the plan of the organization of International E-Conference, and today the Department of Physics has made it successful. For making event successful, every possible is now being taken by all the members of the physics department. Of the conference where the fields be the resource persons, the information provided by the intellectuals will increase your level of the knowledge.
in the researcher perspectives. Once again, I congratulate to staff member of physics department and wish you all the best. Thank you. Thank you very much.
Thank you, sir, for your presidential remarks. Now I request our honorable HOD Physics, Professor B.B. Navle, sir, to pay vote of thanks. Professor Navle, sir, it's over to you.
Okay, I am.
Yes.
Yes, sir.
Welcome you, all of you, everyone. I am honored to have opportunity to give vote of thanks on this occasion of validity function of today's international conference on recent trends in nanomaterials and its applications. First of all, I am like to give my heartily thanks to Secretary, all directors of Sangwar Taluka Shetkari Shikshan Prasad Mandal for giving an opportunity in organizing this type of international event. Also, I am thankful to all resource persons and foreign delegates who enlightening this international e-conference. I am heartily thankful to chief guest of this validity function, Dr. Anamika Adam, with the professor at Institute of Science at DST, giving excellent and informative speech. I would like to express our deep gratitude to Chairperson, Acting Principal, Dr. R.A. Phule sir, for expressing some of this e-conference and their great thoughts. I would like to our convener. It's very important to thanks to active convener of this e-conference, and also he is IQAC coordinator, Dr. Yashish Dhasal sir, and organizing secretary, Dr. G.B. Thomre sir, for successfully arranging this type of great event. I am also thankful to our lab assistant attendant, Mr. Kumar Sadigle sir, for this event, and also for technical support. Also, I am thankful to give their feedback about the conference, and finally, thankful to all participants for the support and making this event success. Now, commission of this over to
Okay, thank you. Thank you one and all. The feedback link will be shared shortly on the Telegram group. After submission of the feedback link, automatically you will get the certificate of the conference. We will meet on the Telegram group for more discussion. Thank you. Goodbye.